Are you ready to give Deadrail a try? A few more things to think about and learn before starting into Deadrail. General information continued, Part 2. Advantages of Deadrail. 1. Using it can improve the reliability and provide smoother overall running of the locomotives. 2. Using it can eliminate or at least simplify track wiring. 3. Track and wheel cleaning becomes almost a moot point. 4. The frogs of turnouts do not have to be powered for the locomotive to run smoothly through them. 5. Reverse loops do not need special wiring to change the track polarity. Advantages of Deadrail continued. 6. Ys with 3 diverging routes are not a problem. 7. There can be no short circuit in the track as the track is not powered. 8. No current keeping electronic device needs to be added to the locomotive to keep the power alive over dead spots in the track. 9. It enhances the enjoyment of the model railroading experience by not experiencing problems because of dirty track or pickup wheels. Direct current DC operation of locomotives uses a DC voltage change to adjust the motor's RPM and thus the locomotive's speed. A switch is used on the unit providing the DC power to reverse the track's polarity for reverse operation. Digital Command Control, DCC, allows multiple locomotives to run independently on the same section of track. DCC uses digital signals sent through the tracks to communicate with individual locomotives and some accessories. Each piece of equipment requires a decoder to decode the signal and make the equipment operate. It also provides the electrical power for the motor through the track. Deadrail does not use any connection to the track. Therefore, some type of wireless communication, mostly radio frequency, RF, not infrared, is used to communicate with the locomotive's very special decoder or receiver. Bluetooth and Wi-Fi are also broadcast using a RF signal. With no connection to the track, these special decoders or receivers are powered by battery DC. These special decoders or receivers provide the information to move the locomotive and optionally turn on the lights, blow a horn or whistle, ring the bell, etc. If you already have hobbies or a job that makes you handy with your hands, that helps a lot. It also helps if you are fairly good at problem solving. It helps to either have a model railroad now or to have had one in the past, but it is not necessary. Tools and supplies that are useful when converting to Deadrail. Decoder installation. A fine tip grounded adjustable heat soldering station for electronics. Thin diameter solder for electronics. Flux for electronics. Wire cutters. Wire strippers for small diameter wires. Multimeter. X-Acto type knife with number 11 blade, extra hand device to hold wires while soldering, small flat blade and Phillips or JIS screwdrivers, tapes, Kapton, masking, double-sided foam sticky, small needle nose pliers, tweezers. Battery installation. All of the previously mentioned tools and Dremel tool with assorted bits, sanding blocks and assorted sandpaper grades, pin vise with assortment of tiny bits, small drill bits, 1/16 inch, 3/32 inch, and maybe 1/8 inch, electric hand drill, small diameter hookup wire appropriate for the motor amp draw to go from the decoder to the battery pack. For HO, I'm using 28 AWG gauge stranded wire. Knowing how to take a locomotive apart is very useful information. Sometimes you can tell from a parts diagram that might be provided with the locomotive how to take it apart. My IHC 280 consolidation was figured out that way, but sometimes you can't figure it out. A search on YouTube can provide the needed information. I found YouTube videos that showed how my Walthers EMD GP15-1 and Athearn RS3 RTR came apart. To illustrate the kind of information you can find, if you look long enough, I've linked to the videos I used in the description below. No matter what scale the locomotive is in, from HO up through the largest garden scales, the vast majority of dead rail conversions use a trailing battery car of some type. There are exceptions based on the locomotive's physical size and internal component layout, the type of battery or battery pack chosen, and how the battery will be charged. Looking at the YouTube Dead Rail Battery on Board videos for model railroads again will show that the vast majority use a trailing battery car of some type, regardless of the locomotive size. Soldering, a very important skill for creating a dead rail locomotive. With the right tools and techniques, it is easier than you think. There are no ready for dead rail locomotives available at this time. Soldering well is an essential skill. I have provided links to 4 YouTube soldering videos that could help you learn or reinforce the best practices when it comes to soldering the electronic components used for dead rail. They are linked in the description below. Resizing the browser window, as shown in the screen capture, makes reading my website much easier. I suggest that my website should be checked at least on a monthly basis to see what I've learned, relearned, and where I'm going next with this project. In August of 2025, new and revised information was added to my website. If you have questions to ask or comments to share, my email address is linked at the top of my webpage. I would love to hear from you.